The graph over 1 of y equals 1 over negative 2x squared minus 0.5 was reflected and its image is shown. So we want to find the equation of this red graph. This graph isn't the red graph because it says right here its image is shown. So we want to find the equation of this red graph. And this is a place where I find that thinking of function notation can often help us figure out our actual equation. Okay? But we'll first try to do this with just the actual equation. If I'm reflecting in the x-axis, okay? If I'm reflecting in the x-axis, that would be a vertical reflection. How do we have our vertical reflection? If it's going to be a vertical reflection, that negative is going to be outside the function. So our equation of this red graph would be a negative outside of the function 1 over negative 2x squared minus 0.5. That's one way we could look at this graph. Sometimes people like to think of, okay, it's my y that's getting multiplied by a negative. Sometimes people like to say then it's my y values that are getting multiplied by a negative. Can you see that this equation is the same as this equation? I have just multiplied both sides by -1 and moved the negative over to the other side. Some people like this because it seems easy, say, vertical reflections. That makes our y change to negative, so I'll put a negative with my y. Horizontal reflections, that makes my x change, so then I would put the negative with my x. So these are the same. I'm going to erase this one right now. If we think about this in function notation, okay, if I think about a vertical reflection in function notation, that looks like this, right? How do these two relate? Well, when I look at this, it's just negative my original function. Can you see that that's what I have? If I put a green brackets here, that's my original function. And I've just put a negative in front. Okay? So if you left your answer like this, it would be right. But sometimes when we check our answer with the answer in the back of the book, sometimes our form doesn't match up with the form in the back of a book. So how could I simplify this equation? What does a negative in front of a fraction mean? Well, another good math strategy is when you're dealing with, I'm going to call this a complex algebraic fraction. There's a lot of stuff in there, right? When you see this fraction, how many people when they see this fraction automatically have this graph pop in their head? 0. None of us, right? Because it's complex. It's not something that you have, right? So a great mathematical strategy when dealing with things is to think of simpler examples. What are all the ways, if I took a regular fraction like 2/3 and put a negative out in front of it, can you tell me another way that I could write that negative so that it's equal? Is this equal to this? Is it equal to this? Is it equal? Which ones of these are right? Which ones are wrong? Think about how fractions work. This one here is the wrong one, right? How do we deal with a negative out in front? All those other ways are fine. Well, a negative is like a -1. Okay? A negative out in front is like a -1. So if I'm looking at negative 2/3, I can think of it as negative 1 times 2/3. That's what a negative 1 in front means. And if I'm multiplying fractions, we know how to multiply fractions. We multiply the top of fraction times the top of the fraction. We multiply the denominator, the bottom of the fraction, times the bottom of the fraction. So if I have a negative 1 out in front, this could also be written as negative 1 over 1. And if the negative was on the top, it would make sense that this is the same as negative 2/3. I could also write that negative 1 as a negative 1 on the bottom. And if I multiplied that by the 2/3, then I would get, oops, 2 over negative 3. Different ways of writing it. In this case in particular, I think there's one that's nicer than the other one. If I was going to put this negative into the fraction, can you see why it might be nice to put it in the bottom of the fraction? It would get rid of a lot of negatives. So if I put that in the bottom of the fraction, if I took this equation and I simplified this by saying it's equal to 1 over negative 1 times by this, and I multiply the top, well, that's just 1 times 1. If I multiply the bottom by the negative, do you see that you would have to distribute it? And you would get positive 2x squared plus 0.5. And I think most likely in most textbooks, they would probably choose that as their answer rather than the negative one. But when you're writing it, this would be right and this would be right. You're not expected to have one form over the other, as long as your form is equal. You can't write something that's different, but if your form is equal to another form, then it's fine. But if you see an answer in the answer key that's different, don't just say, oh, okay, they must just be different, I'm still right. See if you can get that answer. See if you can manipulate it algebraically, because that's where your skills are going to improve with your algebra, to get it to whatever it matches. Because then you can say to yourself, yes, my answer was right, it was just in a different form. And that's a way to check it. Oh yeah, did we ask for anything else here? What is the equation of the image graph? We've done that. That was the only question. What we're going to do for questions here are 7, 8, 9, and 12. And I want you to start with 12. Because 12 involves a little bit more thinking. So I want you to start with that one.